In this video, we're going to solve quadratics by taking square roots. So the equations that we're going to be using square roots to solve are going to be in the form u squared is equal to d, where d is going to be greater than 0. In example A, we have 4x squared is equal to 12. So the first thing that we want to do is we want to get the x squared term alone. And then after that, we're going to get the x term alone. So let's go back to the top. In order to get the x squared term alone, we have 4 times x squared, so we're going to use the opposite operation. And we're going to divide both sides by 4. That gives us x squared is equal to 3. Now, once we have our squared term alone on the left side, we can take the square root of both sides. The square root of x squared is x. The square root is the opposite operation of the exponent of 2. And we're left with, on the right side, the square root of 3. However, anytime you take the square root of a number, anytime you're introducing the square root, our solution is going to be both positive and negative. You may ask yourself, well, why is that true? Well, here's our solution. If we look at this and said, okay, x squared is equal to, in this case, let's look at the positive version. Positive square root of 3 squared. Squared. The square root and the square undo each other, and we're left with 3. So x squared is equal to 3. That was the result when we used positive square root of 3. Let's use negative square root of 3. When we square negative square root of 3, the square root and the square undo each other, and, however, that negative sign is also squared. So we should probably write that a little bit differently so we don't get confused, okay? We can think of this as being negative 1 squared and radical 3 squared. So I'm just rewriting that negative as a negative 1, just so you can see what happens here. Now, when we square negative 1, we're left with positive 1. When we square the square root of 3, we're left with square root of 3, which is just the square root of 3. Excuse me. I misspoke there. When we square the square root of 3, we're left with 3. And 1 times 3 is 3. So you could see in both cases, whether we're squaring positive square root of 3 or negative square root of 3, the result is positive 3. So just as a recap, when using or introducing the square root, you have to remember that the result is both positive and negative. We're going to see that in the next example. So we have x minus 3 quantity squared is equal to 7. So we already have something being squared on the left side by itself. So our goal is to get the x minus 3 alone. And then from there, our goal is to get x alone. So we can take the square root of both sides to start. That undoes the square. We're left with x minus 3 on the left. On the right, we have the square root of 7. But we want to remember this is both positive and negative because we just introduced the square root. And now we're going to add 3 to both sides to get the x alone. Now, we cannot add the 3 to the 7 because the 7 is in a radical. It's considered an unlike term. If we did add it to the 7, we would get something that's not equivalent. So the end result we can write as 3 plus or minus the square root of 7. And really, I generally write my answers like this, but this truly means that we have two answers. One is 3 plus the square root of 7, and the other is the 3 minus the square root of 7. Okay, so those two answers I boxed in are the same thing. Let's look at one more example. So here we have quantity 3x minus 6 squared minus 18 equals 0. In order to use square roots, we need to get something squared alone on either the left side or the right side. So I'm going to work to get 3x minus 6 squared alone on the left side so that I can take the square root of that. And then after I get the square root of that, I'll be left with 3x minus 6 on the left. And then I'm going to work to get the 3x alone. And then I'm going to work to get x alone. So you can see the progression of how I'm going to solve this equation. So first I'm going to add 18 to both sides. I have my 3x minus 6 quantity squared alone. Now I'm going to take the square root of both sides. Those undo each other on the left. On the right, I'm left with the square root of 18. I'm going to leave that as the square root of 18 right now, and I'm going to talk a little bit about that soon. So I can't forget my plus or minus sign because I just introduced the square root. Now I'm going to work to get my 3x alone. I'm going to add 6 on both sides. This becomes 6 plus or minus the square root of 18, remembering that there are two answers there. And now to get my x term alone, I'm going to divide both sides by 3. And I'm going to write this as 6 plus or minus the square root of 18 divided by 3. I'm going to circle this as my answer, or box that in as my answer, knowing, though, that that is not simplified. So I want to talk a little bit about simplifying this. So in order to simplify my answer, the first thing I need to do is simplify the square root of 18. So to simplify square roots, what I want to do is I want to take 18 and I want to rewrite it using factors that are perfect squares. So I know that 18 can be written as 9 times 2. So the square root of 18 is equivalent to the square root of 9 times 2. I can use properties of exponents or radicals to rewrite that as square root of 9 times the square root of 2. The square root of 9 is 3. The square root of 2 is not a perfect square, so I'm just going to rewrite that as radical 2, which means that my answer can be written as 6 plus or minus, instead of square root of 18, I'm going to write it as 3 square root of 2 all over 3. And now what I'm going to do is I'm going to distribute this division. Both of these terms are being divided by 3. So I could write this as 6 divided by 3 plus or minus 3 square root of 2 divided by 3. And then I'm going to simplify each one of these fractions. 6 divided by 3 is 2 plus or minus 3 radical 2 divided by 3. I can divide the 3 on the outside because it's not inside a radical. I'm left with just radical 2. So my answer, simplified, is 2 plus or minus radical 2.